this video, we're going to look at condensing and expanding logarithms. So this is going to tie into this, I guess, series we're doing over logarithms. Be sure to like, subscribe, share with somebody if you enjoy this video, or like this video if it helps you. Also, feel free to reach out in the comments if you have questions over anything. So when we look at condensing and expanding logarithms, there's three different properties we have to worry about. So there is the product property, which we'll go over in a second. So product, there is the quotient, and then there is the power property. All right, so I'm just going to go through each of these one by one, and we'll look at condensing and expanding at the same time, just because it's a lot easier to do it all together. If we split it up, sometimes it can get confusing. All right, so if I gave you a logarithm that has a log base b, and we'll say of x, so log base b of x plus log base b of y, there's a property called the product property that actually says we could condense this into one logarithm. As long as these bases are the same for our logarithms, we can condense this into one single logarithm, log base b, but then we can take whatever is in this x and y position and we can multiply those. So this would end up being log base b x y. All right, now let's put some actual numbers in here so that you can see how it's done. But this is the overall general definition of what we're going to be looking at. So let's say we have log base 2 of 7 plus log base 2 of 4. And I said condense this. Now, the key to this is noticing the operation happening in the middle. Okay? Whatever this operation is going to tell you if you should multiply or divide. So for adding, it actually tells us to multiply. So for you, when you're trying to condense a logarithm, I would just give yourself, either write it down, maybe memorize it, give yourself a quick path to say, okay, we're going to go from adding to multiplying. You have to group those together or put those together in your head. All right, so now when we do this, we're going to take these two log base 2's, so here and here, and we're going to condense this into one single logarithm. So a single log. That's the whole goal of condensing, is to make a single logarithm. Sometimes it's not possible, but that's our goal at least. So we're going to say log base 2, and then we're going to bring down this 7 and 4, because that's like what was in our x and y position, or a position if you want to call it that. We are going to multiply those. So 7 times 4. So then this would give us log base 2 of 28. Now, we could evaluate that, but for this video, to keep it short, I'm not going to evaluate that, okay? So now, let me show you expanding real fast with this same exact problem, okay? Because expanding is just going in the opposite direction. When we expand a logarithm, now we start off with a single logarithm, and we'll have maybe multiplication, and we can use that to tell us to add, all right? So let's do the same problem, but watch how we can expand it instead of condense. So let's say I give you log base 2 of 28. Now, you could do this several different ways. So the answers may vary on this, but I'm going to do it just like we did condensing. When we condensed, we started out with log base 7 or log base 2 of 7 plus log base 2 of 4. We're going to try to get back to that, okay? So let's see if we can do it. So first of all, if we're expanding, we're going to take these log base 2's and we're going to try to expand it out now. We're going to make more of them, okay? So now, if I look at 28, I can say, okay, I know 7 times 4 is 28. Now, obviously, you could pick other numbers. You could say 14 times 2. You could do that as well. So that's why I said the answers may vary. But if we use 7 times 4, we can say, okay, I can make this log base 2 of 7 and this log base 2 of 4, and then all I have to do is remember that multiplication and adding go together. So I'm going to add in the middle, and now you would have fully expanded this out. So you can see that condensing and expanding are essentially the same process, except one is breaking down and condensing. It's making one single logarithm, and expanding is making more logarithms, right? So let's do another one, and we'll do it the same way. We'll condense and expand at the same time. Let's say I gave you log of 25 plus log of 4. Now, once again, remember, anytime you just see a log, it has an understood base of 10. All right, that's not really super important for this, other than to know that both these logs have a base 10, which means they're compatible. We can condense them into one single log, and it'll still be just log base 10. All right, so now addition tells us to multiply, and we're going to multiply 25 and 4, which would give us our single logarithm, log of 100, which I believe this is equal to 10. But like I said, for right now, let's just worry about the condensing. In a separate video, I've already done some of the simplifying, so you can be sure to check that out if you need it. All right, so now let's do the opposite direction. Let's go and let's condense this, and I'll try to fit it here actually. Let's say I give you log of 100, and I say, hey, break that apart and expand it. So if we want to expand this, once again, we're going to make this two separate logarithms. But now we need to figure out, okay, how should we split up 100? And let's just do it the same way it was done over here. We can say 25 times, which I can't write for some reason. We'll say 25 times 4. So we know that we can make this 25, this first logarithm. The second logarithm we can make 4. And then what operation are we going to do in the middle? Since we're multiplying, we're going to add. And that logarithm would now be condensed. Or expanded, excuse me. So, once again, hopefully you're getting the idea of this whole expanding and condensing format. So now, let's look at another one. I do want to make a note here real quick. Let me just show you, how about this? I'll just let you practice this one actually. Let's say you had log base 4 of 2x plus log base 4 of 4x squared. Condense that for me real fast. All right, so we would put this into one single logarithm. But now, addition tells us to multiply. We're multiplying 2x and 4x squared. Do you remember what that would give us? It would give us 8x to the third. So for this, sometimes you have to use your exponent knowledge, exponent rule knowledge, and multiply two variables with exponents, which will mean to add the exponents. All right, so hopefully you got that. So let's move on to the next property, which this is called the quotient property, which if you know what quotient means, it's pretty obvious. So if we have log base b of x minus log base b of y, we could condense that and we could make it log base b, so we're making it a single logarithm, and then we can take x and divide it by y. So subtraction tells us to divide when we're condensing. So if I were you, once again, you could just write condense and then write minus, draw an arrow to that, and say divide. And it actually goes the opposite direction if you're expanding. But there's a little cheat sheet or cheat code for how we condense a logarithm when we're subtracting. So let's practice that real fast. Let's say we have log base 3 of 24 minus log base 3 of 8. So, once again, we are looking to condense this logarithm. So we want to make this one single log base 3. Now, here's always a good question. What if instead of 3, this said like log base 4? That would mean that we couldn't condense this. You can only condense a logarithm into a single log base 3 if everything is a log base 3, okay? Usually I get asked that question every time I do this. All right, so now we're going to take subtraction, and we're going to have to make sure we know, okay, that means divide. And what are we dividing? We're dividing 24 and 8. Okay, so now you could probably do this, but I'll draw it out anyway. This is going to simplify into log base 3 of 3, which once again, we could figure out what that is and simplify it, but I'm just not going to worry about it for right now. I think this would end up being 1 maybe, yeah. But for now, let's not worry about that. So now let's go the opposite direction. Let's expand this out. So now our end goal is log base 3. Well, actually, we can just do it however we want. Maybe I'll make a point here that you can do it different ways. Let's say I gave you log base 3 of 3, and I said, hey, you tell me how to expand this out. Well, the last problem we started with log base 3 of 24 minus log base 3 of 8. Instead of ending up there, watch how the answers can vary. We could end up at a different place, okay? Let's say I expanded this and I made this log base 3 and log base 3. So we want to create more log base 3s. We know we're going to subtract in the middle because we're trying to use the quotient property, which means divide. So we're going to try to subtract here. Now, there's several ways you could go from two numbers being divided to get you 3. Like I could say 12 and 4 here. That would work. I could say 24 and 8, just like we did over here, and that would be a good answer. We could say 9 and 3. We could say 6 and 2. So there's so many different ways that you could answer this. I'll just leave it like this for now, but all the examples I just wrote would actually be good answers, right? So you can see that the condensing and expanding are, once again, just going opposite directions. All right, so now let's look at one more. Maybe you could practice this. Let's say log base 8 of 4 minus log base 8 of 2. So let's condense that. Well, we're going to make this one log base 8 because condensing means a single logarithm. Minus tells us to divide the 4 and the 2. And what's 4 divided by 2? Well, it's just 2. So log base 8 of 2. That would be our answer. Now, we could also expand this out. Like let's say I gave you log base 8 of 2, and I said, okay, I want you to expand that out. So see if you could do that. Well, just like before, there's so many different ways we could do it, but we could say, all right, we're going to make 2 log base 8s because we want to create more since we're expanding. We're going to put a minus in the middle. So now there's so many different ways we could divide to get 2. Like we could say 6 and 3. We could say 8 and 4, which was the last problem. Or we could say, I don't know, let's just say 12 and 6. So all those answers would be acceptable answers, which I'm putting my 6 in the wrong spot. I don't know why I'm doing that. But all those would be acceptable answers. We just have to make sure that whatever we put in this 12 spot and 6 spot has to divide to give us 2. All right? Now, you can also have variables in these problems. So like, let's see if we could do one more. Log base 4 of x to the 9th minus log base 4 of x to the 2nd. Let's see if you could do that one real fast. All right, so once again, we're condensing. So we want to condense. We're going to condense this into one single log base 4. But now we're going to divide x to the 9th by x squared. Hopefully you remember, when we are dividing and we have exponents, we subtract our 9 and 2, which are our exponents. So this would give us log base 4 of x to the 7th. And that would be our answer when we condense. I won't worry about the expanding for this one, but you at least get the idea that we could expand this if we went the opposite direction. All right, so one more rule, and then we're finished. So let's say that I gave you this. Let's say I gave you y times log base b of x. Okay, now this is going to be a little odd, but here's what we have. We have a number multiplied in front of our logarithm. Now this is the power property or power rule. Essentially, what we can do with this y is that we can make it the exponent for this x. So this could expand out, or I guess condense down, and be log base b of x to the y, which I know seems a little weird with letters, but that's the actual definition or the property for condensing. So you just have to remember this. Once again, this is like a little cheat code. If you have a coefficient or multiplication in front, I won't do the dot. I'll write it out because that looks stupid. I'll do multiply in front of log becomes exponent. That's the shortest way I can write it off the top of my head. So becomes exponent. All right, now, I think this is the easiest property, but I've heard some people say they think it's the hardest property. It's just one of those things that's going to be a person-to-person perspective. So let's practice this real fast. So let's say we have 5 times log base 4 of 2. Now, we don't have any adding or subtracting or anything. We just have multiplication here with this 5. Now, it's easy to see how someone could think, oh, I'm going to expand this out and make this plus. But we're actually being asked in this part of the problem to condense. So to condense this, we want to get rid of this 5 multiplied in front. And it's pretty simple once you get used to it. The 5 just becomes the exponent for 2. So this becomes log base 4 of 2 to the 5th power, which we could simplify that and say log base 4 of 32. All right. Now, you could expand this in a similar way. So let's go ahead and look at that. But hopefully you see that this can be an easy rule if you really just pay attention to this number being multiplied in front. And you can even draw yourself an arrow like I did and literally point it to the number it should be the exponent for. Okay. So now let's go the other way. Let's expand. Let's say I gave you log base 4 of 2 to the 5th power. Well, if that were the case and we wanted to now expand, when you're expanding, you just take this power and you move it to the front of your logarithm and it gets multiplied. So this would become 5 times log base 4 of 2. All right, so now let's do another problem. Let's see if you can do it, because I would imagine most of you could probably do this without my help. 7 times log base 2 of x. So let's condense that. So we want to make this a single logarithm, nothing multiplied in front. All right, so now we have this 7 multiplied in front. And remember, the power property says we move 7 and it becomes the exponent of x. So this becomes log base 2 of x to the 7th. Now, what if I gave you this and said, okay, now expand it back? Well, if we expand, it just means now we don't want exponents, because all exponents can be brought to the front and multiplied in front. So you can see how we end up in the exact same spot that we started. So once again, condensing and expanding are closely related. They are essentially opposite directions or opposite operations of each other. So now let's look at one more just so you can see it. Let's do, and we'll make this one a little bit more complicated. We'll say, let's say we have 1/3, actually maybe we'll do 2 more. 1/3 times log of 8. Okay, so once again, we want to condense this. So we want to make sure that we put this in a form that has a single logarithm, nothing multiplied in front. So where does this 1/3 go? Well, it becomes the exponent for 8. So log of 8 to the 1/3. Now, typically you'll see this rewritten. 1/3, if you remember, and if you haven't seen, I've uploaded videos about this when fractions are exponents. But we can actually make that a cube root of 8, which then we could make that, we could break that down even further, but let's just leave it like this for now. So this would become the logarithm of the cube root of 8. All right, now let's look at an expanding problem, because there's a few of these that can get a little bit more difficult. Let's say you have 3 times log base, or just log of 4 to the x minus 1. Now, this is a more advanced problem, but let's just try it. We want to expand this out now. So if I expand this, remember, I want to get rid of all exponents. And here's my exponent, x to the 1. So see if you could figure out what to do with that. So you would move this to the front and multiply it. However, you would have to notice something's already there being multiplied. So the way you would write this is 3 times, or 3 parentheses, x minus 1 log of 4, which means you would have to distribute this. So you would say 3x minus 3 log, well, times log of 4. And that would be how we expand it out. Okay, now let me show you one more just so you can see it, because occasionally you'll come across this setup. If I gave you log base 7 of x, and it's the square root of x. Well, you may be thinking, well, there's no way to expand this because I don't see an exponent. However, you could rewrite x, the square root of x, as x to the 1/2 power, which once again, I've covered that in a previous video, so be sure to check that out if you need to. So our exponent is actually 1/2, and we're going to move that to the front when we're expanding. So 1/2 times log base 7 of x, and that would be expanded. So once again, this is just a quick video trying to give you a simple guide. I mean, I left out a few more complex examples, but like I said, if you come across something that you think is just extremely difficult, feel free to comment and I can reach out and give you some help if you need it.